good afternoon everyone. So let's discuss about weekly contest 141. So let's start from the fourth question. So fourth question is about shortest common subsequence, super sequence. So it's basically a subsequence that can string 1 and string 2 both is a subsequence of the string we want to produce, and the string we want to produce is the shortest string that can have string 1 and string 2 as its subsequence. So the trick is we need to find the longest subsequence of the longest common subsequence of the string 1 and string 2, and basically it's represented as an array. So if we see the array here, if it's the same string, like B and C is not the same, so we goes up by 1, and then check the B and A is not the same, so we keep going up 1. So now it's B and B, so B and B is the same, then we goes 1 diagonal up here, so the B becomes A and A become A, so it's still the same. Then we go up again and then we insert the C. So here we can save the A and B because every time we move a diagonal, basically we save one character from the subsequence we want to produce. So this is the code for the longest common subsequence, and then the second one, basically we trace back the array we already produced, and every time we move a diagonal, which the condition is here, it's basically saving one character from the result we want to produce, and the rest we insert as usual if it's not part of the longest common subsequence. And let's move on to the next question. So next question is about the shortest path in binary matrix. It's basically we need to find a way from initial point 0, 0 to n-1, n-1 with collision there. So 0 is the path that is walkable. Basically that is the understanding of the question, and we can walk using at directional. So basically we can solve it using a normal BFS and using a path cost. So this is a cost to visit a grid of ij, and I initially make it as integer max value, and then I initialize x direction. So we start from the initial position of 0, 0, and then we loop through all the other direction and then register those direction as a cost plus 1 of our from our current grid, and then we add those grid into the next open list to be visited next. And the condition here is just to check like if to make sure it's not out of the grid, and to make sure it is a valid path to walk. If it's a 1, then it's a collision and we don't want to add it into the open list. So after everything is finished, and basically we will end up with 2 different outputs. So the first output is if the grid n-1, n-1 is equals to integer max value, basically it means it's untouched since the beginning, so it means it's not visitable. Then it demands us to return -1 here, and then otherwise we return path cost plus 1. The reason plus 1 here is because the initial cost here I write it as 0. We actually can write it as a 1. Yeah. So yeah, this is basically a normal BFS solution, and let's move on to the second question. So second question here is about this is a greedy method, so largest value from label. So we have a lot of item, and each item have label, but from each of the label we can only use until certain limit. So for example, if we have a lot of label 1 here, like we have 2 of label 1, we can only use 1 of the label 1. Like this 5 and 4, we can only use the 5. We cannot take the 4 together with us because each label can only be used as much as the limit. And number wanted is basically the item we can take regardless of the category. So this problem we can solve using a greedy method by sorting the array by the value itself. So we start from the biggest value, and we need a counter to make sure we not off limit of every category. So I create an item class, and this is basically the counter of each category and count. So if we already taken it, I will increment it by 1. So if you see here, if this label haven't been taken up to the limit, then we will increment it by 1, means we already taken it, and count plus plus, and then taken value plus current value. So taken value is the output we expect. So we assume we will take this item, and since we already sorted by value from the largest to the lowest, so if the larger one is off limit because of the category, because of the label, then we simply ignore it and go to next smaller value from it. And from there, if the count is already as much as the number we wanted, and basically we break from it and then print the taken value. Yeah. And first question, the easy question, this one is a bit tricky because it want to be the array to be written in place. So so what it want is we rewrite the array, but if we make we made an array 0, it basically want us to insert a 0 here, and then everything is being offset. And like for example here, this one, it expect become 1 0 0 2 3 0 0 4 until here, because both of the 0 is being grown up from like 1 in the array to become 2 in the array. So the rest of the 2 element is being eliminated. So yeah, it's so first we can calculate until what index we want to read. And one tricky part is when we have for example here we have a case like 1 2 3 1 2 0 3 1 2 3 1 2 3 0 3, and this one is the normal case 1 2 3, and then become 1 2 3 0 0. But we do have the case like for example 1 2 0 0 3. So in this case we take the 1, we take the 2. On our first 0 we produce 2 0, on second 0 we can only produce 1 0. So this is the corner case that we don't want to add both 0 in, but only half of the 0. So that is the case I'm handling here. So the off is at most 1, because we might grow up more than the expected array, so we mark the off as 1, and then if the off is 1, then we only consume it once to insert the 0 once from the back. Otherwise we insert the 0 twice from the back if the off is 0. And yeah, the rest of it is the same. So if the case of the array is not 0, then we just rewrite it as usual. So the key point here is we need to write the array from the back to the start, and we need to figure out what is the index we want to start with. So yeah, we can calculate it from the beginning. If it's 0, we plus 2 to the last index. Sorry, last index is the starting point. Yeah, so we plus the count by 2, and once the count is finished, then we remember the last I we visited. So this is the index we want to start with. Yeah, and that's basically it. So yeah, this is the weekly contest 141. So let's see you all again on next weekly contest. Thank you.